Picture this. A man stands in a dusty Colorado laboratory. Not quite as dusty as mine here. Surrounded by crackling lightning bolts that literally light up the night sky. While others might run from such raw power, Nikola Tesla calmly sketches in his notebooks, visualizing how these lightning-like discharges could one day wirelessly power cities. This wasn't just dramatic showmanship. It was Tesla's unique mind at work, transforming vivid mental imagery into world-changing innovations. But what if you could harness that same ability to see solutions others miss, that others don't see? To visualize complex systems with perfect clarity and translate abstract concepts into practical innovations. Tesla's thinking methods weren't just suited for electrical engineering. They offer a powerful framework for tracking today's most challenging problems, from sustainable energy to artificial intelligence. In this episode, I'm going to decode Tesla's distinctive cognitive approach that led to his over 300 patents and innovations that we still rely on today. You'll learn how to combine his visualization techniques, his systematic thinking, his innovative problem-solving methods to transform your own creative and analytical capabilities. So whether you're an engineer, an entrepreneur, or a creative professional, an artist, Tesla's mental models can help you see beyond conventional limitations and bring your boldest ideas to life. So what are the foundations? Tesla's cognitive framework was built on three distinct mental models that set him apart from his contemporaries and continue to offer valuable lessons for modern innovation. First was his extraordinary capacity for mental visualization. Unlike most inventors who relied on physical prototypes, Tesla could fully construct and test all the machines, all of his ideas in his mind with remarkable precision. He famously said, "The moment one constructs a device to carry into practice a crude idea, he finds himself unavoidably engrossed with the details of that apparatus." As he continues improving and reconstructing, his force of concentration diminishes. He would put so much effort in that he would visualize this, and then once he solved it, then it was off to implement. This approach aligns closely with what we discussed in our creative thinking series as aesthetic thinking, seeing not just the surface appearance, but the complete harmony of form and function. The second pillar for Tesla was his systems thinking approach, viewing every problem within its larger context. When working on alternating current, Tesla didn't just focus on individual components. He envisioned developing the complete system, from generating to transmitting to utilizing electrical power. This comprehensive perspective connects directly to our earlier discussions on systems thinking, where understanding interconnections lead to more effective solutions. The third foundation was his unique combination of divergent and convergent thinking. Tesla would generate numerous possible solutions through intense visualization, that's his divergent thinking, but then rigorously test each one mentally before attempting any physical construction, and that is his convergent thinking. This dual approach helped him to avoid many of the costly trial and error cycles that slowed other inventors. These mental models weren't just theoretical, they led to breakthrough innovations like the alternating current motor, wireless transmissions, and the fundamental principles of robotics. Each success reinforced the effectiveness of his cognitive approach, creating a self-reinforcing cycle of innovation. So, how did Tesla think through? How did he solve problems? Well, his way of solving problems can be broken down into specific steps that anyone can learn and anyone can apply. So let's examine this approach. First up was he would always do initial visualization. Before touching any tools or materials, Tesla would first construct a complete mental image of the problem and potential solutions. This stage involved seeing not just the surface elements, but each and every component and every interaction in perfect detail. Next up was his mental simulation. Once the initial visualization was complete, Tesla would run mental simulations, operating the devices in his mind and observing its behavior under different conditions. He claimed to run these simulations for weeks or months, noting any flaws or areas for improvement. Next was systematic refinement. Rather than jumping to physical prototypes, Tesla would methodically refine his mental models, adjusting and improving until he thought the design was perfect in his mind. This step saved considerable time and resources compared to physical trial and error. Then came physical verification. Only after exhausting mental testing would Tesla move to physical construction. By this point, his designs were so well developed, they often worked on the first attempt. And then integration thinking. Throughout the process, Tesla constantly considered how his solutions would integrate with existing systems and future developments. This forward-thinking approach helped ensure his innovations had lasting impact. Each step was crucial to his success. So for instance, when he was developing his alternating current motor, Tesla spent years mentally refining the design before construction. When he finally built the first AC motor, it worked exactly as he had envisioned. So, how do you practically apply this? Tesla's thinking methods can be applied to a lot of our modern challenges, but here's how contemporary innovators are adapting his approach. Well, one is mental prototyping in modern design. Companies like SpaceX and Tesla, now I'm talking about the company here, not the individual, have revolutionized their industries by adopting advanced visualization and simulation approaches that mirror Tesla's mental prototyping method. Before building their first reusable rocket, SpaceX engineers spent months detailing in virtual simulations. They modeled every aspect of the launch and landing process. This approach, while more technologically enabled than Tesla, the individual's pure visualization model, it follows the same principle of thorough pre-physical testing. Similarly, automotive companies now use sophisticated virtual reality environments, digital twins, to design and test vehicles before creating physical prototypes. This saves millions in development costs and, more importantly, allows for the kind of rapid iteration improvement that Tesla achieved through his mental simulations. Systems integration and technology. Modern tech companies are increasingly adopting Tesla's systems thinking approach to tackling complex challenges. Apple's success demonstrates this perfectly. Their ecosystem isn't just a collection of products and partners and suppliers, but a carefully orchestrated network where each element enhances the others. When Apple designs a new device, they consider not just its individual features, but how it will interact with their entire ecosystems of products, services, partners, and ultimately the user experience. Amazon provides another compelling example of this systems integration thinking. Their expansion from online bookstore to global technology giant required the kind of comprehensive system visualization that Tesla was known for. Each new service or product they launch, whether it's from AWS or drone delivery, is designed to integrate seamlessly with their existing infrastructure while opening possibilities for future expansion. So, organizations globally are increasingly using visualization techniques in problem solving, often combining Tesla's methods with modern tools. These include product development. Modern product teams use visual thinking tools like digital twins and augmented reality to map out their product ecosystem and their experience well before they ever do anything. Companies like IDEO have developed specific methods that combine Tesla's visualization principles with contemporary design thinking approaches. For example, when developing new medical devices, teams create detailed mental models of the entire usage journey, from physician training to patient experience, before any physical prototypes begin. Another example is infrastructure planning. Urban planners and architects now use Tesla-inspired systems thinking to design smart cities that integrate transportation, energy, and communications networks. Projects like Saudi Arabia's NEOM demonstrate this approach, where planners must visualize and simulate the interaction of multiple complex systems years before a single shovel of dirt in construction begins. This comprehensive visualization process helps identify potential problems and opportunities that might be missed in traditional planning approaches. And let's not overlook innovation processes. Companies like Google and Microsoft have integrated visualization techniques deeply into their innovation processes. Google's Moonshot or X development specifically requires teams to mentally model and simulate their ideas extensively before receiving resources for physical development. This approach has led to breakthrough projects in areas like self-driving cars and internet-provided services internationally. And let's not overlook scientific research. Research institutions are applying Tesla's visualization methods to complex scientific challenges. So, for instance, climate scientists use mental modeling combined with computer simulations to understand and predict weather patterns. Quantum physics researchers often employ Tesla-like visualization techniques to conceptualize and work with phenomena that cannot be directly observed. But while Tesla's methods are powerful, they're not perfect. They come with potential challenges that needs to be addressed. One is overthinking versus action. One of Tesla's most significant challenges was getting caught in the perfection trap. He sometimes spent years mentally refining his inventions, seeking an ideal solution, while competitors moved forward with, quote, good enough implementations. This tendency ultimately cost him several commercial opportunities, most notably in radio technology, where Marconi achieved practical success while Tesla continued to refine his system. The solution isn't to abandon thorough mental modeling, but to establish clear development milestones. Modern companies like Toyota balance visualization with their minimum viable product, or the MVP approach, allowing for both thorough planning and timely implementation. They set specific criteria for when to move from mental modeling to physical prototyping, ensuring momentum while maintaining quality. Another challenge with Tesla's model is integration complexity. Tesla's comprehensive approach to system design can become overwhelming when applied to today's highly interconnected technologies. For instance, developing a modern smartphone involves understanding and integrating hundreds and thousands of subsystems, from hardware components to software interfaces to network protocols. To manage this complexity, successful organizations must use a modular approach while maintaining Tesla's system overarching perspective. So what do? Well, you break down the complex systems into manageable modules. You define clear interfaces between each of these modules. You maintain awareness of system-wide interactions and dependencies. You use hierarchical visualization techniques. It's like peeling the onion. And you employ modern modeling tools to support the mental visualization. Companies like Microsoft use this approach in software development, breaking down complex applications into microservices while maintaining a clear vision of the overall systems architecture. Another challenge with Tesla's approach is mental fatigue and cognitive load. Tesla's intense visualization practices reportedly led to periods of mental exhaustion and occasionally nervous breakdowns. In today's fast-paced innovation environment, this kind of burnout is at even greater risk. Modern practitioners can manage this challenge through structured visualization sessions with very defined time limits. Do it for 30 minutes and then take a break. Give yourself regular breaks and mental reset periods. Go work on something completely different. Use external tools like 3D modeling, simulation software, digital twins to supplement your mental visualization. Collaborative visualization practices that distribute the cognitive load. Share it with others. You don't have to do it all your own. And here's one that I probably need to listen to more often than I do: regular physical exercise and mental wellness practices. Organizations like SpaceX combine intensive visualization work with regular team rotations and structured breaks. This is to maintain peak cognitive performance while pushing innovation boundaries. So, let's spark your creativity. So, how do you exercise, test, and see if Tesla's methods work for you? Well, let's walk through a practical exercise that captures his core approach to his visualization and problem solving. So, how are we going to do this? Choose a simple device you use daily, perhaps your coffee maker or a smartphone charger. Find a quiet space where you will not be interrupted for about 20 minutes. Now, let's think like Tesla. 1. Start with pure visualization. Close your eyes, picture your chosen device. Don't see its outer shell. Mentally disassemble it. Visualize every component, how they fit together, how energy or materials flow through the system. This is how Tesla began every invention, with clear, detailed mental imagery. It could be of an existing thing like your power charger, or mentally understanding the problem. 2. Run your mental simulation. Now make your mental image move. See the details device operating in your mind. Watch energy flow through it. Observe where friction occurs, where heat builds up, where efficiency is lost. Tesla would spend hours in this state, finding flaws and opportunities in his mental models. 3. Reimagine and improve. Here's where it gets interesting. Start modifying your mental model. What if you change the energy source, or rearrange the components, or combine it with another device? Let your mind explore possibilities while maintaining that clear and detailed visualization. So how'd you do? Did you come up with something interesting? Share what you discovered during this exercise with our community. Post it down in the comments, post it over on social media using the hashtag TeslaThinking, and let's see what comes up. So what surprised you? What was the unexpected that happened for whatever your chosen device was? And what improvement did you envision? Remember, Tesla's genius wasn't just in his inability to visualize, it was in his patience to fully develop ideas in his mind before touching any tools. Practice this method of deep visualization regularly, and you'll begin to see the world of possibilities that Tesla was chasing. So what's next? Well, we've just covered Tesla. The next episode, we're going to cover Thomas Edison. Thomas Edison's radically different approach to innovation shaped the modern world. While Tesla perfected his innovations through mental simulations, Edison's systematic experimentation transformed failures into successes. This contrasting method offers a fascinating glimpse into two powerful ways of thinking that shaped our technological landscape: Nikola Tesla, Thomas Edison. So you want to subscribe now and hit that notification bell to ensure you don't miss the Edison story and other upcoming episodes exploring history's greatest innovators and what mental skills, thinking skills, creativity skills they used to create their most impactful innovations. If you find the value in these deep dives into thinking methods and skills, consider supporting this channel by joining the YouTube channel as a member or over on Patreon. Your support makes future episodes possible. Now, go forward, bring your innovations to life. The world is waiting for your unique vision to become a reality.